In this first one, I want to show you the best manual way of computing cross products. We want to do the cross product of u and v. This is a determinant. We put our bars and start our first row as I, j, and k. Our second row needs to be the first vector of the cross product. That would be 3, negative 1, 2. And then the bottom row is the next vector, v, negative 2, 0, 1. And we're going to do the process of expansion by cofactors. Here's how that goes. We're going to take the top row and expand by row 1. To do that, we write the I, the J, and the K. We will have a determinant on the front of each of those. And here's how we come up with that determinant. For the I here, we're going to imagine eliminating the top row and the first column where the I is. The four numbers that are left, negative 1, 2, 0, 1, is our new determinant. On the J, we're going to cross out the top row and the J column, and that leaves us with a 3, 2, negative 2, and 1. And likewise for the K, we're going to cross out the K column and the row at the top and write down what's left. That's 3, negative 1, and negative 2, 0. Then we evaluate each of those determinants. To evaluate this determinant, we multiply negative 1 times 1. We multiply 2 times 0. And we put a minus in between. To do this second one, we multiply 3 times 1. We multiply 2 times negative 2. And put a minus in between. And on the last one, we multiply 3 times 0. We multiply negative 2 times negative 1. Put a minus in between. Now, the signs, since we're expanding about the first row, are going to be positive, negative, and positive. They always alternate, positives and negatives. And depending on where you start, you either start with a positive or start with a negative. Had we started down here on the second row with the 3, we would have come out with a different pattern of positives and negatives. So this is a negative 1i. This is 3 plus 4 is 7 with a minus on it. And negative 2k. So that's the expansion. So that's the vector, if we write it in component form, negative 1, negative 7, negative 2. However, they wanted it in terms of standard unit vectors, which is the I, J, and K. And our final answer needs to be the unit vector. So we need to find the magnitude of this. That would be 1 squared, 7 squared, and 2 squared. So that's square root of 54, which was the same as 6 times 9, which is a 3 root 6. So that's the magnitude. And so our answer is going to be negative 1 over 3 root 6 I minus 7 over 3 root 6j and minus 2 over 3 root 6k. I'm going to show you how to do the cross product and the unit vector for this on the calculator, but first we do have a little bit extra work on this problem because we need to find the vector u and v. Now vector u is from A to B, that's here, so that's going to be 1 minus 1 and negative 1 minus 0 and 3 minus 1. And the vector v is going to be from A to C, which is 0 minus 1, 0 minus 0, and 5 minus 1. Now we need to do the cross product. I'm going to show you this on the calculator. On the TI-89, it's handier to enter the vectors first so you don't have to keep typing all of that, and we'll do that with the bracket key. So here is how we type a vector on the TI-89. This is going to be our u vector, 0, negative 1, and 2. We enter those with brackets. Now we're going to store that, the STO key is on the bottom left, as vector u, alpha and u. So now we have that as our vector u. We do the same thing for v, bracket, negative 1, 0, 4, close bracket, store alpha v. So there are our two vectors. Here is how we do the cross product. If you go to the catalog and scroll down to the C's, C-R-O-S-S-P stands for cross product. We do the cross product of u, comma, v. And there it is. It's the same thing we did just a moment ago with the determinant. We can find the unit vector for that by doing catalog, go to the U's, and UNITV stands for unit vector. Now we can go up here and grab the answer and just push enter and close the parentheses. Here's the unit vector. So the stuff that we just done in the previous one manually, we did here on the calculator. Now of course they were asking us to write this in linear combination form. So we have a negative 4 root 21 over 21i and a negative 2 root 21 over 21j and a negative root 21 over 21k. That's our answer.